Hi students, welcome to this channel. We are studying mathematics class 9. In that we are studying chapter 2, that is polynomials. In previous parts we have completed all the concept up to exercise 2.4. Also in the last video we have seen the identities part. All 8 identities I have completed and we studied identities along with certain examples. So now let us continue with the most biggest exercise of this chapter, and this is at the end, exercise 2.5. In total we have 16 different questions containing other questions as well. So that is why quickly we will go through this exercise. So starting with question number 1. Question number 1 is, using suitable identities, find out the following products. So we are going to use different identities and then we will be solving the products. Clear? So for your convenience I will be writing the identities, whatever identity we are using, just besides the question. Right now first, second and third question are based on same identity, that is x plus a into x plus b is equal to x square plus a plus b x plus ab, sum and product of those two numbers. So before solving this question, always try to check that the first term of both is same and we have two different numbers. Clear? So let us start the solution. Here we have x square plus a is 4 and b is 10. So we will be writing 4 plus 10. Don't forget to write the x, and then we will multiply 4 and 10. Clear? So moving on to the answer, that is x square plus 4 plus 10 is 14x plus 4 tens are 40. So this is our answer. Question number 2, based on same identity. So again the first term is x plus 8 plus minus 10. This you take care while doing the simplification. Okay, wherever there is second term and minus, I have put the bracket. That leads to x square. Now what is 8 plus minus 10? That will be 8 minus 10, so that is minus 2x. And 8 into minus 10, again it will result into minus 80. So minus sums we will be dealing by this method. Over here, slight change in the question. Here instead of only x that we were solving in first two question, we have a common term of 3x. So squaring will be done for the first term, that is 3x plus 4 plus minus 5. So this is common, and here instead of x again we will write the first term, that is 3x plus the product of two numbers. Solving this, 3 square is 9x square, 4 minus 5 that is minus 1, minus 1 into 3x is minus 3x, and 4 into minus 5 is minus 20. The fourth and fifth sum is based on this identity, x square minus y square equals to x plus y, x minus y. Okay, so this is the method of difference of two squares. Clear? So over here they have given this right hand side, that is why we will move to right hand side to left hand side. Clear? So here difference of two squares, the right hand side is given y square plus 3 by 2, y square minus 3 by 2. So what we will be doing, this is the first term, this is the second term. So what we are doing is squaring of the first term minus squaring of the second term. Clear? That will lead us to the answer y raised to 4 minus 3 square is 9, 2 square is 4. Clear? Same with this question. We have 3 minus 2x, 3 plus 2x. So first term square minus the second term square. So that will be 3 square 9 minus 2 square is 4, x square is x. Moving on to the second question, that is evaluate without multiplying directly. That means we have to consider these numbers just like we are using identities. Clear? So how can we convert this in form of identities? So always remember the shortcut trick. It must be 100 plus something or 100 minus something. Okay. So if 103 is to be represented like 100 plus 3, and 100 plus 107 can be represented as 100 plus 7. So is it like this identity, x plus a, x plus b? Yes. See, first term same, and here we have two different numbers. So we will be using this identity, x square plus a plus b into x plus ab. So ultimately, without multiplying directly means that we have to use the method of identity. Now let us solve this. So this will go like first term square plus addition of those term into first term plus multiplication of those two numbers. Here we have 100 square as 10,000 plus 3 plus 7 is how much? 10. 10 into 100 is 1000 plus 3 sevens are 21. So if you add it, it will be 11021. Clear? So this is our answer. Moving on to this one, here the concept changes. It will be 100 minus something. Of course there are methods in which you can add, like it will be 90 plus 5 and 90 plus 6. Okay, also it can be 100 minus 5 and 100 minus 4. Clear? So again this is the similar kind of identity that we are using. So it will be 100 square plus minus 5 minus 4, minus 5 plus minus 4 will be minus 4 into 100 plus minus 5 into minus 4. Clear? So again 10,000. Here it is minus 9 into 100. So that becomes minus 900. Clear? And minus minus plus 5 fours are 20. Clear? 10,000 minus 900, that is 9,100, and plus 20, that will give 9,120 as the answer. Moving on to this question, which combines addition as well as subtraction. That means 100 plus 4 into 100 minus 4. So here we can see first and second term in both the brackets are same, just plus and minus. So we can use this one, x plus y, x minus y, that will give x square minus y square. Doing the square of first term, that is 100 square, minus the second term, that is 4 square. So 100 square will be 10,000 minus 4 square will be 16. So our answer will be 9,984. Here we have in question 3, factorize the following using appropriate identities. So here what we are doing is going from RHS to LHS. So it certainly looks like x square plus 2xy plus y square, right? And what was that? That was x plus y whole square. Clear? So the hint is we have to convert or show that these first and second terms are perfect square of some numbers, and in between we have plus 2 into those two numbers, right? So following the trick, let us go for the solution. Here 9x square is the square of 3x plus 2 into 2 brackets I am leaving right now. Let us go for this one. Y square is the square of y. Over here we can write 3x, over here we can write y. Now verify. 2 3s are 6 into xy. Yes, it is perfect. So basically we have converted the equation into x square plus 2xy plus y square. And what was the final bracket? The first term plus second term whole square. That means 3x plus y whole square. It can also be written as 3x plus y into 3x plus y whole square. That means 2 times this bracket is repeated. So both the answers are correct. Same way, let us try for this one. 4y square is the square of 2y. Here minus 2 will be from the rule. I am leaving 2 brackets. 1 is the square of 1. If you write 2y and 1 over here and verify the middle term, minus 2 2s are 4y into 1 is 4y. Clear? So we can write this as first term minus the last term whole square, or 2y minus 1 into 2y minus 1. Clear? Now moving on to the third question, that is difference of two squares, right? I hope you remember the identity, difference of two square. So let us convert. X square is the square of x, minus in between, y square is the square of y, and here it is 100, so that is the square of 10. Is x plus y by 10, x minus y by 10. So that is how we will solve according to the identities. Moving on to question number 4. In question 4, it is expand using suitable identity. For whole question, we can see that there are 3 different terms. So we will be using this identity, x plus y plus z whole square equals to x square y square z square plus 2 into x into y, 2 into y into z, 2 into z into x. Clear? So by this, let us solve the first question, that is x plus 2y plus 4z. So here we have first term square, second term square, and third term square. Clear? Now what we have to do? Plus 2 into first two terms, then plus 2 into next two terms, plus 2 into the third and the first terms. Clear? So here we are putting x and 2y, here we are putting 2y and 4z, and here we are putting 4z and x. Clear? First second, second third, third first. Alright, now moving on to the last answer part, that is x square is x square, 2y whole square is 4y square plus 16z square plus 2 2s are 4 xy plus 2 into 2, 4 4s are 16yz plus 2 4s are 8zx. Next we have 2x minus y plus z, squaring the first 3 terms. Here I am putting plus outside but taking y minus with y. Alright, the first is over. Then 2 into first second term, you can see minus I have taken with y, plus 2 into second and third term, and plus 2 into third and first term. 2x square will be 4x square, minus y whole square becomes plus y square, and z square is z square. Now here take care about the sign. 2 into 2, 4 into x into y, so it is minus 4xy. Over here minus 2yz, and over here 2 2s are 4zx. Now solving the third question again by the same method, minus 2x whole square plus 3y whole square plus 2z whole square plus 2 into the first two terms plus 2 into the next two terms, and plus 2 into the third and the first term. Solution of this will be plus 4x square plus 9y square plus 4z square minus 2 2s are 4 3s are 12 xy plus 2 3s are 6 2s are 12 yz minus 2 to the 4 to the 8 zx. Clear? Moving on to the fourth one. The fourth question is 3a minus 7b minus c whole square, and the fifth question is minus 2x plus 5y minus 3z whole square. Now I have done the solution part. Let us quickly see that solution. First term square, second term square, third term square plus 2 into first term second term plus 2 into second term third term plus 2 into third term and first term. Clear? Solution of this 3a square is 9a square minus 7b square becomes 49b square minus c square becomes plus c square. Clear? 2 into 3, 6, 7 are 42, minus sign is there, and AB. Same way, minus minus plus, 2 7 are 14 BC. Here 2 3 are 6 minus CA. Clear? Fifth question. Minus 2x whole square, 5y whole square, minus 3z whole square plus 2 into first two term, then second third term, then 2 into third and first term. Solution of minus 2x square, 4x square, 5y square becomes 25y square, minus 3z square becomes 9z square. 2 into 5 minus 20xy, 2 into 5 10, 3 are minus 30yz, and minus minus plus 2 3 are 6 2 are 12zx. So these two sums are very easy. That is why we have solved initially. Here fraction is there, so let me do it. Following the same identity, it is 1 by 4 a whole square plus minus 1 by 2 b whole square plus 1 square. 2 into first term into second term plus 2 into second term third term plus 2 into third term and first term. Clear? So that is how we will follow the same rule. Just the difference is, instead of normal numbers we have fractions. So don't worry about it. Go on with the same formula. 1 square is 1, 4 square is 16, and a square is a square. Right now 1 square 1 I am showing over here. Even if you want to write a square by 16, then also it is right. Minus 1b square becomes plus b square upon 2 square is 4, plus 1 square is 1 only. Over here you see we have minus sign, so we'll put minus. 2 and 2 can be cancelled. So in numerator we have a into minus b, that becomes minus ab, upon we have 4. Here also we can cancel 2 and 2, and then multiplying the remaining numbers will give minus b. Over here we can cancel 2 1s are 2, 2 2s are 4. Finally it will be a upon 2. So here one thing is new, that cancellation is possible, and that will help us to reduce the multiplication. So that is how we will solve this type of questions. Question number 5 is factorize, and again we have to do it with identity. Here I have written the identity. The difference is that we are going to see the questions of this type, and then we will go for the answer of this type. Clear? So from LHS to RHS it is expansion, from RHS to LHS it is factorization. I hope this is clear. Now these two questions we are going to solve in a very shortcut manner. I will tell you the trick. What you have to do is, the first three terms you have to take care and just write the roots of them in whole square. That means 4x square can be written as 2x whole square. Clear? Plus 9y square can be written as 3y whole square, and finally 16z square can be written as 4z whole square. Clear? Now if you have seen carefully, I have written them into big brackets, so I have left a space if in case there is any negative numbers. Right? Now the important thing is that the next three terms also I am writing by this manner only, plus 2xy plus 2yz plus 2zx. but again you have to leave some space for the negative sign. So 2 into the first two bracket plus 2 into next two bracket plus 2 into another two bracket. Clear? In the first two bracket, let us write 2x and 3y. Next two bracket, let us write 3y and 4z. Then we will write 4z and 2x. Clear? Again big brackets because we have to introduce minus sign as well. Clear? Now check very carefully. In these three terms, you take notice of terms which are negative. So here we have this term negative, this term negative. Clear? Now in these two negative terms, which variable is common? Here you can see yz and xz. Which term is common? Which variable is common? Z. That means over here in this second step, wherever you find any z term, you write that as minus. You put minus sign in front of that. So here we have 4z minus, so keep minus 4z. Are we clear? Right? And the final answer will be, including the first three terms only, 2x plus 3y minus 4z whole square. So this is our answer. Clear? Following the same thing in the second question, but before that let us revise what we did. The first three terms square roots we wrote. Okay, we kept the bracket and we kept space. Then plus 2 into first two term, 2 into next two term, and 2 into next two term. Clear? Now very main step. For minus sign, what we saw, terms containing minus and the common variable. Okay, what we wrote, what we identified, the common variable in negative terms. That common variable we have to identify and just put minus sign in front of that, also in the last answer. So this is our final answer. Clear? Going for the next question, it is very tough. Why I am telling this? Because here there are some numbers whose roots are very tough to find out directly. For your help and convenience, I have given the hint. 2 is the square of root 2 and 8 is the square of 2 root 2. Okay, I am not explaining how, but you learn this. Clear? So now let us solve this, writing the first three terms into square. So this is root 2x whole square plus y whole square plus 2 root 2 z whole square. Clear? Right now, whenever you are doing in your notebook, keep some space for including the minus sign. Plus now the next three terms, 2 into first term, 2 into next two terms, 2 into next two terms. Clear? So first term is root 2x, then we have y. Over here we have y and 2 root 2z. Then we have 2 root 2z and root 2x. Clear? Now before identifying the minus sign, let us write all the three terms, root 2x, y and 2 root 2z. Now let us see what we have in negative term. So here the first negative term is root 2 root 2xy and the second is minus 8xz. Which variable is common? Common we have x. That means below, in both these steps, wherever we find any term containing x, we will put minus. So put minus over here, put minus over here, and put minus over here. Here put minus and plus in remaining. Don't forget to write the whole square. So this is how you will be solving it in short.